Good morning. Now, as usual, whenever I start talking about a new topic, there are a number of people that will come up and argue against what I'm trying to say. And if I'm wrong, I'm really happy for them to put up the counter argument, show the maths, show the theory, and prove me wrong. That way I can learn. But just to say you're wrong, it doesn't work like that. And whatever, that's just wasting my time and confusing people that are looking at what I'm saying. So please, if you want to challenge what I'm doing, challenge it logically, challenge it with the mathematics, and prove me wrong. No problem. Right. So back on this subject of temperatures for radiators and underfloor heating with mixed circuits. So what I'm saying yet again is that we need to be very careful when setting up low temperature heating systems to run underfloor heating and radiators on the same system. And the reason for that is that underfloor heating actually requires a raised temperature at its point of mixing in order to get the energy transfer across that point. And that this temperature could be higher than the temperature required for your radiators. Now, I'm saying could be, it doesn't have to be, and I guess regularly it probably isn't. And the biggest time that it could be a problem is on setback at night, when you might have your underfloor running at, say, 2 degrees setback and your radiators running at maybe, 10 degrees setback, for example. So that the flow temperature required by the radiators and the underfloor, the mixed temperature for the underfloor could be very similar to the mixed temperature for the radiators. And the delta T's matter. They're important. The flow rates through the systems and the delta T's matter. And I thought I would demonstrate this. I haven't actually done the mass flow rate calculus behind this, but they're fairly easy to do. If we assume an underfloor heating system at delta T5, you can use whatever delta T you want for this, and I'll talk about that in a minute. So if we assume an underfloor heating system at delta T5 and a boiler at delta T20, because this is kind of worst case scenario. So this is a point at which you're much more likely to get the issue that I'm trying to point out. So delta T20 and at on this system, and systems matched 5 kilowatts to 5 kilowatts. The flow in the heating system is lower than in the underfloor heating system, so the returns will match. It's the same as distortion theory that Adam Chapman talks about all the time. So basically the returns match. So the boiler adds its 5 kilowatts and it spits the water back out at 55. That whole water blends with the return water from the underfloor and we get a flow temperature of 40. Now if we look at this, the return temperature 35, we add delta T20, which is the delta T of the boiler or the low loss header or the hydraulic separator, and we end up with a flow temperature of 55. So this is the rule that I'm trying to explain. The underfloor heating system flow will require its return temperature plus the delta T of the boiler to be supplied to it in order for it to load match. The rule is correct. Right, and so let's go through this. Right, so now let's say we run the boiler at delta T5, 10. We take that flow, the return temperature is 35, we add 10, comes to 45, so we end up with a system of 45, 35, so it's still hotter. And at delta T5, we've got a flow temperature of 40 and a return of 35, so that's balanced. So this is heat pump territory. This is why I say it doesn't matter with a heat pump about getting this stuff right. We still need mixers, but you could have an unmixed and a mixed circuit, depending on the design flow temperature of each circuit for a heat pump. But when it comes to a boiler, you've got to allow for the difference in delta T across the two systems before you choose which one's going to be a mixed and unmixed, or whether you're going to have an unmixed at all. So, and the other point I keep saying is that if you've got poor underfloor heating, which most systems that are being put in are not well designed, they're being laid out at convenient pipe centres to make it easy to install. And some of them are going at 200, 250, even 300 mil centres, where they can use really high temperatures from old-fashioned heating systems. And then along comes Joe to fit his heat pump, and it's not going to work. They're going to have to dig up that floor and take that underfloor back out and replace it with something with closer centres. So if you've got one of these rubbish underfloor heating systems installed for high temperature, and you come along and put in new radiators to the new Part L, I think it's 55 flow, the chances are you're not going to be able to use an unmixed and a mixed circuit or a sub-mount kit on a Viessmann. The chances are it's not going to work. However, if you've got really, really highly efficient underfloor and bad radiators, then that is almost certainly going to work. But you need to work it out. The problem you've got is that we don't know what the delta T's are going to be in actual life. Some boilers aren't that great at maintaining the delta T's they're supposed to run at. And it's quite possible that a lot of systems would run around delta T10, and delta T10 on the boiler would reduce this issue. Let's say you had delta T7 on the underfloor and delta T10 at the boiler. Well, you're not going to see a lot of difference in these temperatures. They're going to be very close and you won't have an issue. And you might think I'm talking nonsense. But you don't know. And if you can't control it, you can't set it up, and you can't know what it's going, you're taking a risk when you fit the unmixed circuit. And this has certainly happened to me on a couple of occasions. I've had to go back and fit mixing valves take them off the underfloor and put them onto the radiator circuit, because the underfloor heating circuit is the one demanding the higher temperatures. And customers are complaining that the bedrooms, so usually it's a underfloor downstairs and radiator system upstairs, and customers are complaining the bedrooms are too hot, especially at night on setback, and sleeping all night in hot, sweaty rooms, and they don't like it. So I've had to do that twice. I don't want anyone else to have to do it. My general advice is just fit 2 mixers. If you don't know what your outcomes are going to be, or be prepared to go back and fit an extra mixer, or be prepared to go back and transfer the mixer from the underfloor to the radiator circuit. It's not expensive to put a mixed circuit in my mind. Much easier just to put 2 mixed circuits in and know you've got control of both circuits. Another comment was that you do have control of an unmixed circuit, and this is not correct. You will only get control of that circuit if coincidentally the mixed circuit always requires a flow temperature lower than that of the unmixed circuit. Otherwise you lose control and you don't have proper control of it. Anyway, I hope these examples help. It's quite simple. All you need to know is what the delta T's are going to be. You don't even need to do the mass flow rate calculation. If you know it's a delta T5 system and your boiler is going to load match, which it should do, you've got matching returns, and you've got the delta T rise from the return to the flow from the boiler. This does become a little confused if you're running from a low loss header and you also got a radiator circuit coming on there, because there'll be a temperature drop across the low loss header, and probably a little bit of a change in delta T at the low loss header. And again, do we want to calculate all this through? Do we want to take a risk? Do we want to find out we're wrong? Or do we just want to fit 2 mixers in and know we're going to get it right? Well, that's your decision when you're designing a system. Personally, I will not be putting in any unmixed circuits where I'm not absolutely certain that unmixed circuit is going to perform for my customer under the normal operating regime that they put it to, which is setback at night time on radiators and much lower setbacks for underfloor heating. The choice is yours. So I hope that helps, and I hope that finally has cleared up the issue as well. And thank you.